Hello, everybody. All right, so what we're going to focus on today is combinations of functions and composite functions. So we are going to be taking a look at, again, domains of functions, and then we're going to combine functions using the algebraic functions like add, subtract, multiply, divide. And then we're going to form composite functions, and then we're going to determine their domains and then write functions as composites. Okay, so we are going to start with domain. So, finding a function's domain. If a function does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. So basically what that's saying is if I don't tell you, give you a timeline or something like that and tell you that from this time to this time is the only portion we're going to look at, and I just hand you a function, then we're looking at the whole entire domain, and that's going to be the largest set of that. Um, the exception is that you're going to exclude from the domain any real numbers that cause division by zero and real numbers that result in a square root being negative. So these are our restrictions here. So the negative square root and real numbers that cause division by zero. So if those happen, we have to exclude these values. So here we go. We're going to start here. We're going to find the domain of this function. I'm not worried about anything else, not worried about graphing it or anything. I just need to find the domain. And so when I'm dealing with domain, I am going to look, especially when I'm in this rational form here, I'm going to look at the denominator. That's the only thing I care about. And what I want to do is I want to say, okay, if I'm caring about the denominator, I'm going to say, ooh, that's really big. Hold on. Not that. I'm going to say x squared minus 49 is equal to 0. Because I need to know what numbers is going to make this equal 0. So I'm going to go through the process. X squared is equal to 49. I'm going to square root both sides, so my x is equal to plus or minus 7. So when I write my domain, I'm going to have to do something about this here. Because these two numbers, 7 and negative 7, make this denominator right here go to 0. So since these are my only exclusions, this is what I know. I'm going to start at negative infinity, and I'm going to keep going until I get to negative 7. Because I can go all the way up to negative 7, but I just can't include it. That's why it's a parenthesis, not a bracket. And then I'm going to break. So I'm going to bring this into union. And then I'm going to go from negative 7 all the way to positive 7. And I'm going to stop there because it's, again, 7 will give me a denominator of 0. And then I'm going to break. And then I'm going to go from positive 7 all the way to infinity. And that's how I would write my domain for this function. And so you'll notice that you have specific things in here, like this and this. This is a union. So what it's saying is that we're bringing in each of these pieces here. So I have these three pieces, and we're putting them all together. And so what a union does say is that it says I'm going to take this piece here, and this piece here, and this piece here, and we're going to put it all together to make one big domain. And so that is what your domain for this specific piece would actually look like. Now, notice I didn't touch the numerator. Why? Because in this case, there's nothing that is going to be restricted. My numerator can equal 0. That is okay. I don't have a square root sign, so I don't have any restrictions there. So I don't worry about the numerator. However, on this one, there's some work I got to do. So, again, I'm going to start here with my denominator, this piece right here. So I'm going to start there, and I'm going to say, okay, so I've got x squared minus 16. That's going to equal 0. So x squared is equal to a positive 16, so my x is equal to plus or minus 4. So typically that would be enough, and then I could do exactly like I did on my last one. But because I have this piece right here, I've got to deal with this numerator, because now this numerator could possibly have a restriction that is outside of this boundary that we just found right here. So we have to go through that process. So I've got the square root of x plus 4. And so that's going to equal 0. Now, here's the deal. It's not going to equal 0. Why is it not going to equal 0? Because it's okay for this to be equal to 0, but what is this okay not being equal to? This can equal 0, but this also needs to be either greater than or less than what we're going to deal with. So what we're going to do is we're going to go ahead and run this as a 0. Square both sides. That gives me x plus 4 is equal to 0. Move the 4 over. X is equal to negative 4. Now, so this is just so you can see. We're going to come over here. I'm going to make a little sign chart real quick. And I'm going to put my negative 4 here. And then I'm going to pick a number before negative 4. So let's just go negative 5. And after negative 4, well, let's just go 0. 0. Nah, I don't know what that was. And then what we're going to do is we're going to evaluate. So I'm going to say the square root. So negative 5 plus 4. What does that give me? Negative 5 plus 4. That gives me a negative 1. So I get a negative sign here. When I plug in a 0, I get 0 plus 4, which is a positive 4. So I get a positive number right here. So my restriction has to be, remember, square roots cannot be negative, so I cannot have anything on this side, but everything over here is okay. So I have this specific restriction here. So my x cannot equal plus 4 or minus 4 for the denominator. But for my numerator, I actually can't say x is equal to negative 4. I actually have to say that x has to be greater than or equal to negative 4. Because as long as this is a true statement, then my numerator is always going to work. Okay? So this is what we have to do. So since this is one of my restrictions that I have to focus on, I cannot come in from negative infinity like I did in the last one. So here I'm going to start at negative 4. And I'm going to run all the way up to positive 4. Okay. The reason I have to do this is because this takes care of my denominator. So I'm going to start at negative 4, but I can't include it. But notice I don't have any negative infinity because negative infinity would generate a negative square root, and I can't have that. So again, then I'll come up to 4, and then I'm going to connect it. So starting at 4, and then I'm going to run off to positive infinity so I can have anything up in that direction. So when you have a square root in either top or bottom, you more than likely will not go from negative infinity to positive infinity. You're going to have an actual starting and or stopping point. So you just have to pay attention to that. All right. So I hope that makes sense on this piece. Make sure you look at the denominator first. So this is your first. And then you run this whole entire process here, following up with the sign chart, so you know which way that you're going to actually have to go. Okay. All righty. So now let's look at operations. So what's going to happen here is I'm going to give you an f of x, a g of x, a h of x, whatever, and I'm going to have you do specific operations with them. And basically what we're going to do is add, subtract, multiply, and divide. And so you have 4 things that we're actually going to look at here. So these 4 right here, add, subtract, multiply, divide. And then what we're going to do with that is then on some of these you might be asked, what is the domain? And so if you need to look at the domain, then you need to basically go through what we just went through on the rest of them. But when you're adding, when it asks you for this, that means add. So you just take your f of x and add that to your g of x. When you see this means subtraction. That means you take your f of x and you subtract from your g of x. When you see this together, that means you're multiplying. So you take your f of x and multiply it with your g of x. And when you see this piece right here, that means you're dividing. So you take your f of x and divide it by your g of x. So let's jump into this. So the first thing we're going to do here is we are going to combine our functions together, and we're going to find each of the following here. So what I want to do is I want to come over here and say, okay, this one's going to have me add f of x and g of x together. So what I'm looking at is this. I'm going f of x plus g of x. So if that's the case, then I've got my f of x, and I'm going to add that to my g of x. I'm going to clean this up. And when I do that, make sure it's highest exponent first, so x squared, and then plus x, and then minus 6. There's nothing else I can do with this, so this is what f of x plus g of x look like together. And then it's going to ask me for the domain. Sometimes it will and sometimes it won't. So you just have to pay attention to the actual question. So the domain for this, well, I don't have any square roots here. And I don't have any rational functions, which means I don't have a denominator. So my domain is literally going to be from negative infinity to positive infinity. Okay? All right, let's keep going. So we added. So now let's subtract. So I've got f of x minus g of x. So that's going to give me x minus 5 minus x squared minus 1. I'm going to clean this up. So that x minus 5 is just going to sit there, and then minus x squared, and then plus 1. And then put it in order from highest exponent to lowest exponent. Make sure signs go with signs. And I am done. It's pretty much straightforward. You know, this is not something that hopefully you're stressing out over. It should be straightforward and easy. The key thing is make sure you follow your signs here. Make sure they go together. Make sure you put it in order from highest exponent. So it has to be your highest. And it's going to go all the way down to your lowest. Okay? Let's try again. Here we're going to multiply. So this is saying I've got f of x. I'm going to multiply this times g of x. So I've got x minus 5 and then x squared minus 1. FOIL this one out. So I have x cubed minus x minus 5 x squared plus 5, and then clean this up. I said x cubed and I wrote x squared, didn't I? Yep, x cubed. So x cubed minus 5x squared minus x plus 5. And this is what I'm looking for. All right, last one. Now we're going to divide. So this is saying f of x all over g of x. So then I have x minus 5 all over x squared minus 1. So here you have one more thing you have to do. So you have to put, you have to ask yourself, are there values that you must exclude? Because you have to make sure that you are identifying those values. So if they ask you about the they ask you about the domain, you can tell them, all real numbers except. So if I look at here, I have this at the bottom. I don't have a square root on top, so I don't have to do that extra step. But here on the bottom, I have x squared minus 1. Set that equal to 0. So that gives me x squared is equal to 1. So my x is equal to plus or minus 1. So that means when I'm talking about it, another way to write it is in set notation. So a set of all numbers of x such that x cannot equal -1 or +1. So this would be your domain if it asked you for it. And this is your domain. This is what it looks like in set notation as well. So if you're taking a look at this and it wants it in set notation, it wants something like this. If it wants it in interval notation, then you're looking at, again, your domain from -infinity to -1, union, -1 to 1, union, 1 to infinity. But just pay attention on how they want you to actually write your domain, either in set notation or here in interval notation. And that's pretty much how you add, subtract, multiply, divide your functions. Now, 9 times out of 10, your division is just this simple. It's literally going to be taking this function and putting it over in this function, and that's pretty much it. The key is going to be, usually with the division one, is where they're going to ask you about your domain. So just keep that in mind as you go through these problems. All right. So let's take a look at composition. So composition, this is where a lot of people have a little bit of trouble. Composition is what a lot of you call FOG, f of g of x. And so what this is doing, this is taking one function, and you're taking that function and you're inputting it into another function, and then you're cleaning stuff up from there. If it asks about domain, it's going to basically be the domain of whatever the x value in g of x and what it is in the other one as well put together. Okay. So, and we'll talk about that as we get closer to that, so you can actually see what we're actually looking at. It's just usually easier just to go through the process and actually just doing the composition like it's asking you to, and then just finding the domain from that specific composition. So here we go. I've got f of x is equal to 5x plus 6, and g of x is equal to 2x squared minus x minus 1. And what this is asking me to do, this first one here is to find f of g of x. And if I'm finding f of g of x, so what I'm going to do is I'm going to say, okay, if I'm finding f of g of x, this is what I am looking for, is f of g of x. So what it's saying is this. This f here is my focus. So this is my focus piece right here. We are focusing on that. And this piece is the substitution piece. This is what's going to go into my focus. So as I'm looking at this and as I'm doing this, if my focus is F, everywhere I see an X, so I like to highlight. So just come over here and highlight the X. So you're going to insert G of X one time into this whole entire process. So my f of g of x is going to look like this. I've got 5, but instead of an x, I'm going to plug in my g of x, because again, this is my focus, plus 6. So I go 5, and so instead of g of x, I've got 2x squared minus x minus 1 plus 6. So that gives me 10x squared minus 5x minus 5 plus 6. And then I'm going to clean this up as best as I can, which gives me that as my final answer, and I am done. Okay. So I would recommend, until you get comfortable with it, doing this so you can see everywhere that you're going to plug in the other focus piece, so that way you don't lose track. So let's do another one together. Let's go backwards. Let's go g of f of x, because yes, you can actually do that. So what this is saying is my focus has now switched to g, and my substitution piece is the f of x. So what that is saying is I'm going to wind up doing this. I'm going to say 2 instead of x squared. I'm going to say, oops, not g of x, my bad. I'm going to say f of x. And we're going to square that minus f of x minus 1. So everywhere I see an f of x, I'm actually going to substitute this piece in here. So 2 times 5x plus 6 minus 5x plus 6 minus 1. Oh, I forgot the squared. So this becomes 2 times 25x squared. 6 times 5 is 30, double that, plus 60x plus 36 minus 5x minus 6 minus 1. I'm going to keep cleaning this up now. So I get 50x squared plus 120x plus 72 minus 5x minus 6 minus 1. And now I'm just going to keep cleaning stuff up. So I get 50x squared. That one's done. Plus 115x. These two are done. 72 minus 6. That is what? 66 minus 1. So minus, not minus, plus 65. And I am done. So just walk through the process here and, take your time. It's just a lot of algebra. The hardest piece is to figuring out what to put in. Now, I'll tell you what a lot of people do, especially on a problem like this. They always forget to put that number in. Whatever, like 5x plus minus whatever that number is, they usually forget about that piece. And so they'll get like this piece here, they'll get this, but then this is going to be a different number. And so you just got to make sure that you don't forget about that number on the end. All right, so now we have this problem here. So this is a little different. It is, but it isn't. Because now they're saying f of g of 3. They want to know when this piece here is 3, they want to know, well, what is f of g of 3? So basically what they're asking you to do is they're asking you to do this. They're saying, okay, I want you to find f of g of x. And then I want you to evaluate that answer, whatever you found, at, in this case, 3. Okay, so my f of g of x was this guy right here. 10x squared minus 5x plus 1. So my f of g of x was 10x squared minus 5x. I think it was plus 1. Let me make sure. Yes, plus 1. And so now I want to evaluate this at 3. So this becomes 10 times 3 squared minus 5 times 3 plus 1. So 10 times 9 minus 15 plus 1. That's 90 minus 15 plus 1. So that becomes 75 plus 1, which winds up being 76. And that's my final answer. So if that, for whatever reason, let's say you didn't do this piece here earlier, you can go through and do the first part, or the other way you can do it is like this. You can come over here and say, okay, g of 3. Well, g of 3 is 2 times 3 squared minus 3 minus 1. So that's 2 times 9 minus 3 minus 1. 18 minus 3 minus 1. So 18 minus 3 minus 1, that's 14. So then you can take this answer here, and you're going to plug it into this equation right here. And so then we get my f of 14, and that's going to give me 5 times 14 plus 6. Well, 5 times 14 is 70, plus 6, that gives me 76. And so as you notice, both answers are exactly the same. So if you didn't have the luxury of going ahead and finding out what your g of f of x was earlier, or your f of x, whatever they're asking you to find earlier was, then you can just go through this process here. Whatever answer you get here is what you're going to evaluate your focus on. But notice either way, you get the same answer. All right. So now what you're going to do, I've given you 3 problems here, 1, 2, and 3. So I want you to pause the video here, and I want you to find each one of these, h of f of x, f of g of x, and f of x. And yes, this is actually a real thing here. Okay, so I want you to go through and I want you to try to figure out what these are, and hopefully that you'll get them right and there's no issues, and then we can move on. Okay, so go ahead and pause the video now. All right, welcome back. So let's see how you did. So h of f of x, so my focus is this one, so I've got the square root of 3x minus 2 plus 2. So that will yield me the square root of 3x. So that should be the answer to your first one. The second one, f of g of x, so 3 times 6x squared plus 4x minus 1 minus 2. That's 18x squared plus 12x minus 3 minus 2. So that would be 18x squared plus 12x minus 5. And then our last one. This one's a little tricky, but notice that we're going to do the same thing. So 3 of 3x minus 2 minus 2. 9x minus 6 minus 2. So 9x minus 8. And there you go. So that is how you do those 3. Okay. All right. So that is compositions. So the last thing we're going to quickly talk about is your exclusion values when we deal with compositions. So the following values must be excluded from the x input. If x is not in the domain of g, it must not be in the domain of f of g. Any x for which g of x is not in the domain of f must not be in the domain of f of g of x. So this is just saying is just pay attention. If it doesn't show up in g of x, then it's not going to show up when you compose f of x and g of x together. It's basically what it's saying. So just pay attention to that. And so you've got a problem that looks like this. So they want you to find f of g of x. And so right now, if you take a look at this, for my f of x, my x cannot equal -2. And for my g of x, my x cannot equal 0, which means that both of these two numbers are going to be excluded when we actually do the composition. So when you take a look at this, I got f of g of x, so my focus is this one, and this is my substitution piece. So we have 4 over 1 over x plus 2. This is going to be a little bit of algebra here. So I've got 4 over 1 over x plus 2 over 1. We're going to do an upside down picnic table on the bottom, so I'm going to leave the top alone. And then I'm going to wind up with an x here, and a plus on top, and a 1 and a 2x. And then I'm going to copy dot flip. So I've got a 4 over 1 times x over 1 plus 2x. So this gives me 4x over 1 plus 2x. So in addition to what we already said earlier, if you take a look here, if I took this denominator and I said, okay, I've got 2x plus 1, that's equal to 0. So I got 2x is equal to negative 1, x is equal to negative 1/2. I also have to include my 1/2, or my negative 1/2, I'm sorry. My negative 1/2 as well. Because my negative 1/2 is when I combine the two together. On top of the fact I cannot have 0 and I can't have a negative 2. So these three values here have to be excluded from the domain when we're talking about the composition of this. Okay? And that's simply the fact because we're composing these two functions together. So since you're composing these two functions, that's why we have to include those exclusions, because if we ever decide to go backwards and expand our compositions, we have to be able to look at, okay, well, what can I not include in that as well? Okay. All right, so that concludes composition functions and our combinations of functions in composition. So I hope that wasn't too bad. Again, if you're having any questions, please make sure you're emailing me and sending me reminders and everything else. But if there's nothing else, I hope everybody has a good evening, and I will talk to everybody soon. TTFN. Ta-ta for now.